base of our trebuchet will hold our arm and our counterweight. For our base, we also added a piece of wood in the middle so our projectile could easily sling off. Our counterweight is 30 pounds, so once we release our mechanism, the counterweight will go down and our projectile will go. For our release mechanism, we used 2 eye hooks with a rope connected attached to it, where we stuck a screwdriver between it, and once we release the screwdriver, the projectile should accelerate. Oh, it worked! One, two, three. The history of the trebuchet. First came the sling, then came the catapult, and from the catapult came the trebuchet. Trebuchets were first used in China 2,000 years ago. They were used as both siege and defense weapons. They progressed from China all the way to Europe. It became popular during the medieval times. Engineers of the medieval ages worked hard to develop a better design for the trebuchet to ensure it had a great effect. The force of the trebuchet was capable of reducing castles, fortresses, and cities to rubble. At this time, the design of the trebuchet was revised so that the trebuchet of men used to pull down the ropes were replaced with a large fixed counterbalance weight.
The word trebuchet is derived from the Old French word trebucher, meaning to throw over. The trebuchet is generally associated with throwing stones. A trebuchet could release up to 2,000 stones in one day. They were used to launch stones, sharp wooden poles, darts, fire, casks of burning tar, burning sand, pots of Greek fire, dung, dead and sometimes mutilated bodies, disease-ridden bodies, body parts, dead animals, any rotting matter, and quicklime.
Oh my God.
Making a trebuchet can be extremely difficult, especially since there are a lot of variables you have to take into consideration. Today I will talk about the main 4. These are all the variables you have to take into consideration when designing your trebuchet. The first thing you have to take into consideration is the arm. In order to have the most efficient arm possible, it needs to be in a ratio of 1 to 3.75. So whatever number you have here, it needs to be 3.75 times that. So say you have 1 here, you need to have 3.75 over here. Or 2, and you have to have 7.5 over here, and so on. The second thing you take into consideration is the counterweight. Many people always wonder how much weight they have to put inside the trebuchet in order for it to work efficiently. The answer to that is up to you. You could put as much as you want, but a good number would be 100 times whatever your projectile is. So say your projectile is 10 grams, 100 times that would be 1,000 grams, and that's what you put inside for your counterweight. The third thing you take into consideration is the length of the sling. The length of the sling has to be long enough to release the projectile on time, but short enough to actually release it. The time it is released it is also affected by the fourth and final variable, and that is the angle of your nail. The angle of your nail has to face the direction in which you want your projectile to launch. Lowering the angle of the nail will cause the sling to come out sooner and release the projectile sooner, and changing the angle of the nail higher would cause the sling to release the ball later and shoot the projectile straight into the ground. The next and final thing I'll teach you guys how to do is finding the calculations for your trebuchet in 6 steps. Step 1 is to find your velocity in the horizontal direction, which is your v of x. In our case, Our calculation was that our time was 1.35 seconds and our distance was 10 meters. And to the right I drew a little graph just to show a little basic idea of what's going on. We have our x and we have our time, so what we're looking for is our initial velocity. In this case we ignore this part because gravity does not affect movement in the horizontal direction, so we just cross that out and just plug in your numbers. X was 10, we were looking for our v0, and our time was 1.35. And now what you do is divide everything by 1.35, and that'll give you your initial velocity. And once you do that, you should get an answer of 7.41 rounded to the hundredths place. Step number 2 is to find the time to reach the maximum height. In order to do that, you have to get your original time, the time it took to do the whole thing, and divide it in half. You have to divide it in half because it takes half of the time to get from where you started to the maximum height, and the other half to reach the floor. Our third step is to find the velocity in the vertical direction, Vy. In order to find this, you use the equation V equals V0 plus AT. But in this case, I replaced the V0 with the Vy because that's what we're looking for. And what I did was plug in a 0 for the final velocity, and the acceleration is also gravity, so I plugged in a -10. And the time was the time we found in step 2, which was 0.675. Then I just multiplied the -10 and 0.675, which gave me that, and just added that to the other side, which gave me the answer of 6.75 meters per second. Step 4 is to find the velocity at an angle. In order to do that, you have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. We know our a squared and b squared because that's what we found in steps 3, which was 6.75, and step 1, which was 7.41. So you plug those into the a squared plus b squared, and that gives you an answer of 54.91 plus 45.56. And what we're looking for is our c squared. So when you add those up together, it gives you 100.4725, and then you have to square root that in order to get rid of the c squared, and that leaves you with the c of 10.02. Step 5 is to find your angle. In order to find your angle, you use tangent theta equals opposite over adjacent, and this is where your graph comes handy. Right here is where my theta is, and I got 6.75 from my velocity in the y direction and 7.41 in my velocity in the x direction. So I just got these two numbers and plugged them into the equation. And in order to find your angle, you have to multiply tangent by the opposite of it, which leaves theta alone, and then whatever you do on one side you have to do to the other. So you just plug all this into the calculator, and that gives you an answer of 42. Our sixth and final step is to find the max height. We use the kinematics equation y equals v0 t plus 1/2 at squared. But I changed the v0 to a vy because that's the direction in which the velocity is moving for the distance we're looking for. So what you do is you're looking for y, and you plug in your vy, which is what you found in step 3, which is 6.75. And then your time, which is the time you found in step 2, which is 0.675. And you leave the 1/2. Your acceleration is -10 because of gravity, and you do the same time but squared. So when you plug this all into the calculator, it should give you with all this, and your final answer should be 2.278125. But rounded could be 2.28.